Hey, welcome back, my dear friends. Let's continue with another important topic today in this fourth video. So, if you can recollect, in the past three videos that we did about determinants, how we calculate determinants. Then we learned about minors. Then we learned about cofactors, and of course, we also learned about how to find out the adjoint of a given matrix. So, let's move one step ahead now, that is how to find out the inverse of a matrix, that is using determinant method. Now, but before that, of course, this topic I did not discuss, so I'll be discussing clearly again in some other videos, that is like what are actually invertible matrices, or what do you mean by inverse of a given matrix. Now it is nothing but a square matrix A of order n, that is definitely a square matrix, is said to be invertible if there exists another square matrix B of order, again same order, such that, now note here, such that the product of A into B, the two matrices, also equal to B into A. This is possible. Why? Because we are talking of a square matrix, so order will remain the same, 2 by 2 or n by n. Then when the product of these two matrices both ways results in an identity matrix of that particular order, then in that case B will be called as the inverse of the matrix A and is denoted by A inverse. That's something like 3. What is the multiplicative inverse of 3? It is 1 by 3, because 3 into its multiplicative inverse gives us the multiplicative identity, that is 1. So this is the concept behind inverse of a matrix or invertible matrices. So some things that we should note here is like every matrix is absolutely not invertible, because like rectangular matrices are definitely not invertible, because rectangular matrices A B may be possible, but B A we do not know, it may not be possible, isn't it, for rectangular matrices. But for square matrices this is never a problem, so that's why. So these are some things. And another note is like, for like, I'll just write in short, like if inverse of a matrix exists, then it is unique in the sense like every matrix will have only one peculiar unique matrix. That means a matrix A cannot have like more than 1, 2, 3 different invertible matrices, because 3 into only 1 by 3 is also like only 1, isn't it? Multiplicative identity, that is matrix A into just one matrix will give us the identity matrix. That's why invertible matrices and their inverse are unique to each other, so they will also be unique. That means if the inverse of the matrix exists, then it will be, of course, unique. That means if you're told to find out the inverse of a given matrix, it shall be unique. You cannot have 2 or more different types of matrices which tend to be the inverse of just one single matrix. That is not possible. Okay, so another theorem is like, one more theorem that happens is like, I'll just not write down the statement, you will find that plenty in the textbooks. Please go through it. The reading of textbook is a very good habit. Please develop that habit. If A and B are invertible matrices of the same order, then what happens is A into B, inverse of the product of matrix A into B, will also be, I'll not be going for the proof of this, the independent product of the matrix B and A, B inverse into A inverse. Now in this exercise, what we are going to learn is there are 2-3 different ways to find out inverse of a given matrix. How do we find out the inverse of a given matrix? There are 2-3 different ways. Here we will be learning how to find out the inverse of a matrix using the determinant method. Now before that, that is a very important note. A square matrix A is invertible if and only if A is non-singular matrix. That is, this is one way of identifying. As I told, every matrix does not have its inverse. There are some matrices whose inverse may not exist, so we need to be careful with that, and that is one way of finding out. That is, a square matrix A is invertible if and only if A is non-singular matrix. Now, as we had seen, non-singular matrices are those matrices whose determinant is not equal to 0. Singular matrix whose determinant is equal to 0. This is non-singular, and this will be called as singular matrix. This will be called as non-singular matrix. So singular matrices are those matrices whose determinant is equal to 0. Not equal to 0, then it is non-singular. And how do you find out the determinant of a matrix? Then the very important part, that is, inverse of a matrix is determined by the adjoint of the matrix A divided upon by the determinant of the given matrix. So this is the formula that we will use using the determinant method. There is another method which we will be learning in class 12, that is called the elementary row transformations in matrix. So very soon we'll do a video on that particular topic also. For now, let us learn how to find out the inverse of a matrix using this determinant method. Now that will be for question number 5, that is from exercise 4.5, of course. That is, find the inverse. Find the inverse if it exists. So question number 5, if it, let us name the matrix A, 2 minus 2 4 3. If it exists, how do we find whether it exists or not? Very simple. Let's find out its determinant. So 2 3s are 6, minus 4 2s are minus 8, so 6 plus 8, that shall be 14. So since this is not equal to 0, the inverse, of course, definitely exists because it is a non-singular matrix. So now for that, so determinant of A we have already calculated. We need now adjoint of A. For adjoint of A, as we had seen, as we have already done, let's find out the minors first, then the cofactors, then only we proceed. So M11 will be 3, M12 will be 4, M21 and M22 will be 2. So C11 will be C12, C21, C22 will be M11 minus M11 minus M21, M22. So I wrote 111. That is not possible for now, isn't it? In that case, we'll have to go 11 by 111 by 111 matrix. Wow, that's really going to be interesting. Minus 4, 2, 2. So the adjoint of our matrix A will be given by the matrix formed by the transpose of the cofactors. So that's 3, 2, minus 4, 2. So ultimately our inverse will be one adjoint of the matrix A divided by its determinant. Our determinant was 14, and 3, 2, minus 4, 2. So this is the inverse of our given matrix, exercise 4.5. Let's just verify the answers. Please hold on a second. So question number 5, exactly so. So this is the inverse of our given matrix. So I believe that you are clear with the concept of inverse of a matrix. That is, if A is a given matrix, then another matrix B such that A into B or B into A should give us the identity matrix of that particular order, then that particular matrix will be called as the inverse of the given matrix. So, and how to find out the inverse of a matrix? This is the method using determinants method. So likewise we can have 3 by 3 matrix also, and so on. So I would like you to solve this exercise. Stay at home, stay safe. From the team of Teach Nagaland, we request you to stay at home, stay safe, but be active, do exercises, do your maths problems, do your physics problems, keep in touch with the books, which will keep you always busy. So do not let your brain just remain idle, do something. So we wish you all the best. If you have liked our videos, please do comment on the section below, and please help us reach more and more subscribers so that we can be helpful to maximum of the students. Thank you from the team of Teach Nagaland.